Yes, we're back. Welcome. Whatever. Anyway, today we've made it to Friday the 22nd. I don't know how. These 2 weeks, man, these have been incredibly long weeks. My goodness. Again, the plan is that we're all coming back on Monday for midterms. Your midterm is scheduled to take place on Tuesday, the 26th. Now, just for the sake of argument, I am not going to be doing a YouTube broadcast on Tuesday, the 26th, simply because you are taking your midterm. Instead, I will be doing a Google Meet. So for those of you that are virtual on the 26th, I will put a reminder into the Google Classroom that we will be using the Google Meet to get that thing done. And then everyone will be in here, and then we will knock out said midterm. Now, there it is. I had the paper. I was told that you guys had this mailed home to you or some junk like that, with like the midterm schedule. So obviously you do know it's on Tuesday. It says 7:10 to 9:24. I want to assume that 7:10 would be like the beginning of like a few minutes right there, where technically that would be like a homeroom thing. And then we'd, get everything set up and get started. So I don't know. We'll figure that junk out. Yeah, man. Again, like so I got 2 weeks of teaching to an empty classroom and just teaching to you guys online. And then I got one more week next week where I don't get to teach. And it's like, I just get to give midterms. That's fun. Just for the sake of argument again, Friday the 29th is supposedly scheduled to be an A day. So I will not see you on Friday the 29th. And not only is it scheduled to be an A day, but it is also scheduled to be the first day of the third marking period, just in case anybody needs to you need to mentally kind of prepare for that, because some of you change classes if you take half your courses. So whatever. In the meantime, as people have graciously done, please make sure you're throwing a comment into the chat, and that would be fantastic, and we'll all high five at the end. I do apologize. It completely slipped my mind to post that quizzes, which, again, in fairness, it was a practice quizzes. And I would like to go over some of those questions here with you today, based on the ones who were able to take it. Again, it was practice. It didn't count against you. If you didn't do it, that's no harm, no foul. But again, I completely forgot to post it until before the end of the workday yesterday. So anyway. So that's actually what I would like to start with. I would like to start with going over some of those multiple choice questions. He says, say something. Oh, because I told you to say something. Shut up, Dylan. Anyway, sorry, I'm like a little slow in the uptake today, but we'll figure that junk out. But yeah, my goal is to go over some of those multiple choice questions after today, and I will make a note for myself to do this. But I should be making. I'm going to remake that quizzes available to you for practice purposes, where you get to see the answers during and after and things of that nature. But we'll figure that junk out. So multiple choice questions first, and then I would like to wrap up with the free response questions that I had picked out from the other day, because we only went through half of them. And then, we'll get this thing moving. So as always, if there are any questions while I am going over these, by all means, throw those questions into the chat. I will have that open at my desk, and we'll figure this out. So first things first, let me go to the quizzes in question. so I could take a look at the report that was given for that thing. I don't want to view the quiz. I wanted to view the, oh, I'd have to end it. Yeah, okay, let me end that assignment then. Or can I go to the dashboard? Yeah, I'm going to go to the dashboard. So I'm going to end that assignment. Cool. And then, will it allow me to see the flashcards? No, I don't want to reattempt it. I just wanted to go over set questions. So, okay, so here's the overview. Okay, good. So I'll open the quiz here, and then we'll just start with questions 6 and 7, since those seem to be the most read at the moment. Okay. So questions 6 and 7. Now, you may not be able to see this from exactly where you're sitting because the screen is terrible. But I'm going to try and read this as best I can. And again, like I said, I am going to make these questions available to you one more time, just in case you wanted to practice these multiple choice questions again. So the question is, a consumer group for a camping and hiking magazine would like to compare a new mosquito spray made with essential oils to a traditional spray that contains DEET. The group is interested in the amount of time the spray protects the wearer from the I can't even talk today. Bloodthirsty insects. Subjects will be treated and sent into a mosquito-filled meadow. Sorry, that just made me laugh. For a 12-hour period. Which of the following is the best method for assigning the treatments? Now, again, without actually having read any of the responses, I know in terms of assigning treatments, there has to be some level of randomization. So let me just kind of go through them one at a time here. Have the subjects choose which, no, I'm going to immediately bypass that one. Why would you have them choose which spray they're willing to use? That clearly is not random. Okay. Assign the sprays to the subjects on the basis of their camping and hiking experience. Again, it says without randomization. Screw that. Give the new spray to all subjects for a 12-hour period, then give them DEET spray to all subjects for a 12-hour period. Now, that could work, except at that point, you wouldn't know whether it was the new spray or the old spray that was effective, or the old spray was contaminated by the first spray, or something along those lines. Again, there has to be random assignment. Randomly assign the subjects to 2 groups, giving the new spray to one group and DEET spray to the second group. That seems like the best option. And then lastly, each subject uses a randomization device to select which spray to apply to the right side of their body, and the other spray is then applied to the left side of their body. Again, in theory, that's an interesting idea, but because we're dealing with actual sprays, they could contaminate each other. Yeah, it has to be that. Randomly assign each group, or subject to 2 groups, one of 2 groups. Random assignment has to make sense in the context of the problem. Let's see here. Question 7 also seemed to be one that gave people a bit of issue. Again, I'm going to verbalize this one because you can't really see it that well. But an education researcher would like to give a survey to a stratified random sample of students in a large school district using grade level as a strata. Okay. Which of the following would not be a characteristic of this stratified sample? A random sample of students will be chosen. Well, yeah, that's given. They're saying which one will not be a characteristic. Each student in the population belongs to one stratum. Yeah, I mean, grade level, 9, 10, 11, 12. The population of students will be divided into homogeneous groups by grade level. Yeah, we just said that. Proportional numbers of students could be selected from each grade level. I mean, they could be, but that's not a requirement. I'll come back to that one. Every possible subset of the population of students in the district has the same chance of being selected. No, absolutely not. Not that last one. Yep, there it is. That last one is every possible subset is in reference to a simple random sample. If every possible subset had the same chance of being selected, it would be a simple random sample. But that's not what this thing talked about. It talked about it being a stratified random sample, meaning that they would separate them into their individual strata, the Boston, the cream, the chocolate. They would separate them into those groups and then sample a little bit from each group. So every possible subset? No, because one subset could just be everybody who's a senior, and that's not possible with a stratified random sample here. Okay, now I don't want to do 8. I just want to get back to here. There we go. 9, 10, 11, 12. Let's talk about those. 9. Okay. Students taking an exam at Westwood High School were randomly selected to receive either a peppermint candy or a similar looking candy without peppermint to determine if peppermint really improves thinking. Well, I'm going to read the rest of this in a moment, but I'm thinking, like, doesn't peppermint have like a strong taste to it? Wouldn't they know that the candy that they're eating does not have peppermint? Unless they're not being told, hey, here's a peppermint candy. Whatever, I'm overthinking this. Both groups showed an increase in test scores. Okay, this sounds like a placebo effect problem. I'm not even, I'm going to show the answer. There it is, the placebo effect. The placebo effect is when you have multiple groups within an experiment in which one receives the treatment and one receives a fake treatment, the placebo. But the fake treatment group showed just as much change as the group with the treatment. That is the placebo effect. Okay. 10. I already gave away the answer. All right. I'll read it anyway. A small town employs 34 salaried non-union employees. Each employee receives an annual salary increase of between $500 and $2,000 based on a performance review by the mayor's staff. Okay. Some employees are members of the mayor's political party. Ooh, a scandal. And the rest are not. Students at the local high school form 2 lists, A and B. One for the raises granted to employees who are in the mayor's party, and the other for raises who are granted to employees who are not. They want to display a graph of the salary increases in the student newspaper that readers can use to judge whether the two groups of employees have been treated in a reasonably equitable manner. Okay, which of the following displays is least likely to be useful? Well, automatically, a scatter plot, I can see why the scatter plot would immediately not be helpful at all. Yes, both pieces of data are technically quantitative data. But when you are dealing with a scatter plot, the two data points in question have to be linked. So if you have a scatter plot with a bunch of different dots, the assumption is that that one individual dot will have some kind of a link between the X variable and the Y variable. But if you are just posting, okay, here's list A, all of their salaries. Here's list B, all of their salaries. Where's the connection between the two? Yes, you separated them by political party with the mayor against the mayor, but there has to be a discernible link. Like, for example, height and shoe size. One individual person has that connection between their own height and their own shoe size. But if you're talking about random person, Joe Schmo over there who received this, who's part of the mayor's political party and received a raise, and Joe, something over there, I don't know, some other Joe, who was not a part of the political party and received a raise. There's no direct connection between the two. I can totally see why a scatter plot would be useless at that point. Yeah, histograms, box plots, they would all be helpful. Not that scatter plot. Ooh, back-to-back stem plots. Stem plot below shows the yearly earnings per share of stock for two different companies over a 16-year period. Okay, which of the following is true? The median of, hold on, before I even read about the medians or anything like that, something I wanted to kind of draw on the board here, and I think that you would be able to see it. I think that you'd be able to see it based on the fact that the glare is just below it. But something that I would want to point out, is the shape of this thing. Where the peaks are actually happening, both peaks are happening at approximately the same location, but in a very, very slight manner. That stem and leaf plot to the right for company B seems to be a bit more symmetric. And for company A, it seems a bit more skewed. In fact, yes, the peak is happening right here in the 1 category, but for company A, there's nothing less than that. And they have way more data points in that $3 range. So I think it's fair to say that company A is skewed to the right. The reason why that is important to recognize right off the bat, because I just peeked at some of these choices and they talked about the median and the mean, and I'm like, oh, hold up, let me just kind of study this a little bit more before I look at the choices. And this is also a good strategy for you. Kind of think about what you need to recognize before you even look at the choices. If company B is skewed to the right, that would mean, I'm sorry, not company B, company A. I wrote skewed under company A. If company A is skewed to the right, that would mean that their average would be pulled towards that direction to the right. Their average would be pulled up. The median would be about here, and the average might be a little bit higher, the mean, that is. Whereas for company B, since it's a bit more symmetric, it is more likely that for company B, that the median and the mean would be approximately the same number. So thinking about those pieces of information, now let me read my choices here. The median of the earnings of company A is less than the median of the earnings of company B. No, I can't prove that. I mean, I could find the actual numbers, but let me just read the rest real quick. The range of the earnings of company A is, okay, I could calculate that too. The third quarter, oh man. Okay, the mean of the earnings of company A is greater than the mean of the earnings of company B. I mean, I just talked about that, how the mean for company A was pulled forward. I wonder if that's just the answer by itself. And I don't actually have to calculate the rest. I would love to see that I'm right. And then I could just easily high five myself. The last choice is talking about the mean of company A being larger. Yes! I don't have to do any calculations. It's just based on the shape of that stem and leaf plot. You could determine symmetry or skewedness, and because of that skewedness in company A, that mean was pulled forward. It was pulled higher than wherever the median was. Yes, you could take your time and calculate the median and the range and the quartile, and you could even take all of that time in the world and calculate the mean of both companies. However, as a reminder for the AP test that you are taking in May, you only have 2 minutes, 15 seconds on average per question. 2 minutes, 15 seconds on average. It would take up, not a long time, but it would take some extra time to have to do those calculations when you could easily figure out that that is the answer based on the shape of these distributions. Food for thought. Okay. I'm going to take a small break from the multiple choice, and I'm going to go hit up a free response question. Reminder, in your Google Classroom, I posted the PDF of the, there it is. I posted the PDF of the midterm review, questions and answers. So I'm going to go to the questions. I'm going to hit up one of those free response questions, and then we'll return to some more multiple choice, if I feel like it. We left off on a problem from 2004, Form B. I'll bring it up on the screen right here. It looks like this. So if you're following along, it is the question from 2004, Form B, number 1. The Earth's moon has many impact craters that were created when the inner solar system was subjected to heavy bombardment of small celestial bodies. Scientists studied 11 impact craters on the moon to determine whether there was any relationship between the age of the craters, based on radioactive dating of lunar rocks, and the impact rate as deduced from the density of the craters. The data are displayed in the scatterplot below. Now, again, just looking at that scatterplot, not having read any of the questions, that scatterplot appears to be an exponential decay. It appears to be an exponential decay. That's something that you should be able to visibly recognize based on the way that that scatterplot looks. Age in billions of years, impact rate grams per millions of years. Oh no, it's 10 to whatever. That's a weird calculation. All right, whatever. Part A. Describe the nature of the relationship between impact rate and age. Oh, okay. If I'm going to be talking about the relationship, basically the association, what the scatter plot is actually showing me, perhaps that I should describe it using strength, form, direction, and outliers. That's what we did with scatter plots. Now, clearly this is not linear. Could you call it exponential? You could call it exponential if you wanted to, but I think that just to be safe, because I clearly see there's trying to do some form of a regression down below, I think it would be safer just to say it was nonlinear. I would say that there is a strong, because I mean, look at that decay. It just looks almost so perfect. I mean, maybe it's exponential, maybe it's something else, but it does look like there's a direct pattern in this thing. I would say that there's a strong nonlinear negative relationship between age and impact rate. You could say something along those lines. I mean, you can even describe what it does. You can even say that it appears like an exponential decay. That's up to you. Prior to fitting a linear model, the researchers transformed both impact rate and age using logarithms. Ooh, interesting. Look at this. I'm going to zoom in on this. I want to point something out to you. Look at that table. Look at that table right there. Now, I did not teach you Algebra 2. I did not teach you Algebra 2. But I am expecting that you do recognize what the heck is going on with this ln. It is the natural logarithm. It is log base e. We'll see what happens with that, but let's just see what happens. Okay, so they did the following output, and the residual plot was produced. Again, with these kinds of tables, typically you can ignore the SE coefficient. You can SE coefficient. You could ignore the T. You could ignore the P. You can ignore the R squared adjusted. Typically, I just really need the coefficients, which they actually threw into an equation for me. They threw that into the equation already. That's good. Thank you, AP graders, whatever. And they gave me the R squared. But let's see what the next question's actually asking. Where's my question? Was the question cut off? Oh man, was my question cut off? I really think it was. Oh, this is gonna make me sad. There's like 2 more parts to this question. Oh, goodness gracious. Let me bring it up. Hold on. Let me bring it up on the screen right here because I have it somewhere. I think it just got cut off in the Word document. Took me a few moments just to find it here. Nope, those are the scoring guidelines. I'm going to have to actually provide that question for you as well. Mixed Messiah. 2004 Form B questions, and this is question number 1. This is ridiculous. Why did... Oh, that's what got cut off. Ridiculous. Okay. Screenshot that. Paint. Let me cut that. It should take me just another moment. I can throw it into a Word doc and blow this thing up on the screen. There we go. Here's actually the rest of the question. It's ridiculous that this thing didn't actually show up the way that I wanted it to. But what they give you here, and I'm going to have to, there we go. See it a little bit better. What they give you here on the next page, which again, you don't have, but I will provide for you. They give you a residual plot. Now the residual plot, I'm assuming, because it says prior to fitting a linear regression model, the researchers transformed the data, and then the output and residual plot were produced. Okay, so this output was the residual plot based on the transformed data. That's interesting because there does seem to be a little bit of a pattern here still. There still seems to be a pattern. So I don't know if natural log may have been the best option for refitting this data. All right, well, part B, interpret the value of R squared. R squared in that output was 89.4%. Well, I could say something. Now, keep in mind that that 89.4% is based on the transformed data. And if you go back to this page, yeah. If you go back to this page right here, I just want to emphasize something. The fact that they transformed, or they refit the data with a natural log on the X values and a natural log on the Y values. They actually did both here. So that's something to keep in mind when talking about R squared. R squared is 89.4%. So I could say 89.4% of the variability in the natural log of impact rate. I would have to specify that. Let me repeat that. 89.4% of the variability in the natural log of impact rate can be explained by a linear model on the natural log of the age of the crater. Something along those lines. That's a weird statement to make, I know, but let me repeat exactly what I just said. 89.4% of the natural log of the impact rate, the Y value, can be explained by the linear model on the natural log of the age of the crater. That's such a weird way of putting it, I know, but ugh. But then the even weirder part is when I look at that residual plot, it still does not look great. And in fact, in part C, it says to comment on the appropriateness of this linear regression for modeling the relationship between the transformed variables. And the thing is, there's still a noticeable pattern. I can still see a pattern in that residual plot. It's still not the best. I mean, you could say that, well, the transformed data still is still not appropriate for a linear model based on the fact that there is a pattern in the residual plot. That would be perfectly acceptable. I mean, there's multiple ways of stating that. This problem. Usually, when you get to the AP test, and please notice this. Usually, when you get to the AP test, the first question is not always the easiest. Let me repeat that. the first question is not always the easiest. However, the first question typically does not require a lot of intense calculations. Part A, it said to describe the nature of the relationship between impact rate and age. And then for parts B and C, they wanted to interpret R squared and then comment on the appropriateness of the linear regression. Man. That's usually what number one has in store. Let me do one more of these. Ooh, sweet. We've done this one. We'll talk about this one, then I'll jump back to some multiple choice. We've done this question before. 2011, number 3. I love this question. An apartment building has 9 floors, and each floor has 4 apartments. All right. The building owner wants to install new carpeting in 8 apartments to see how well it wears before she decides whether to replace the carpet in the entire building. The figure below shows the floor of apartments in the building and with their apartment numbers. Only the 9 apartments indicated with an asterisk have children in them. Ooh, children. Now, something just to point out. The intention of the building owner. She wants to see how well the carpets wear in 8 selected apartments to decide whether or not she's going to replace the whole building with carpet. It should be clear when the fact that they mention children, it should be clear that when you have children, things tend to wear a bit faster. Please understand that. When you have children, things tend to wear a bit faster than you intended them to wear. So they really want you to pay attention to the children, especially since they pointed it out with asterisks. But part A. For convenience, the apartment building owner wants to use a cluster sampling method. I'll remind you of that in a moment, in which the floors are clusters to select the 8 apartments. Describe a process for randomly selecting 8 different apartments using this method. Okay. Cluster sampling versus stratified sampling, because I know it comes up later, but they technically, I tend to describe them together. Think of that Boston cream pie. When you are talking about a cluster sample, you are talking about taking a slice of that Boston cream pie. And within that slice, it should be, within theory, representative of the entire population. A cluster sample is a slice where that slice should be representative of the larger population. A stratified sample is when you would take the individual components of that Boston cream pie, separate them, and then sample a little from each strata. So this person wants to use a cluster sampling method in which each floor is a cluster. Each floor is a slice, meaning you would select the entire floor. And if you select the entire floor, then you get 4 apartments. So in theory, because they want 8, you only have to randomly select 2 of the floors. Describe a process for randomly selecting the 8 different apartments from this method. Okay. Easiest way, I mean, you could use a random number generator to select 2 distinct random integers from 1 to 9. Or you could do rand int 1 to 9 to select 2 distinct floors. And I say distinct because you can't select the same floor twice in a row. Or, as a lot of people did, you could write the numbers 1 through 9 on a piece of paper, throw those pieces of paper into a hat, shake well, and then pull out 2 pieces of paper without replacement. And those 2 floors, you would then pick all 4 apartments on that floor. You would have to specify that. You're describing the process for selecting 8 different apartments. Yes, I picked 2 random floors. Good for me. Make sure you also include that statement. Then you would sample Or then you would install new carpet on all apartments on those floors. That would be acceptable. There's 100 ways to do that problem. Part B, an alternative sampling method would be to select a stratified random sample. Ooh, strata. What would be the strata? I wonder if the problem gave me any indication as to what the strata would be. Sorry. Where the strata are apartments with children and apartments with no children. A stratified random sample size of 8 might include 2 selected apartments with children and 6 with no children. In the context of this situation, give one statistical advantage of selecting such a stratified sample as opposed to a cluster sample of 8 apartments using floors as clusters. What you would have to do is you would have to specify that by using this stratified sampling method, you are guaranteed to get apartments with children and without children. But in the context of the situation, you also have to explain why. That is important. Why is it such a big deal that I get apartments both with and without children? Why is it such a big deal that we sample a little bit from each strata? Because then the apartment owner would be able to compare the carpet wear of apartments with and without children, because children tend to wear carpet down faster. It's just a fact. What would be interesting is if they also did a thing about pets. I mean, this is I'm just thinking about something in the future, but it's like, if you wanted to do it by children, that's fine. But then if you also wanted to have a combination of like pets, maybe like apartments with children, apartments without children, apartments with pets, apartments without pets, like that kind of thing. Maybe an apartment with both children and pets. I don't know. Moving on. Let's go back to the multiple choice. Here. Click that. Click that. Okay. Let's take a look at number 12 on the multiple choice. I want to go hit something a little bit more intense right now. Not intense, but let's see. Ooh, 15, 16, 17. What do they have in store? 15, 16, 17. Okay, we'll do 15. A random sample of bears in a national park is taken, and each bear was weighed. Summary statistics for the weights in pounds are provided below. Remember what I said, you're not going to really be ever using true mean in this class, TR mean, so don't worry about that. Oh, interesting. Just for the sake of argument, they also give you standard deviation, but they give you this thing called SE mean. SE mean is something we will see in the future, so I'm not going to worry about that right now. What can be said about the number of outliers? Well, if I'm going to calculate the number of outliers, I'm going to need to do that Q1 minus 1.5 IQR, Q3 plus 1.5 IQR thing one more time. Very quickly, I'm going to calculate the inner quartile range by taking Q3 and minus Q1. I get 130.8. I'll show you these calculations on my screen in a moment. And then I'm going to do 877 minus 1.5 times 130.8. And I'm going to do 1008.5 plus 1.5 times 130.8. There we go. Let me show you exactly what I got here. I calculated the IQR. And then I calculated Q1 minus 1.5 IQR and Q3 plus 1.5 IQR to get that range from 680 to 1204. Anything outside that range is considered to be an outlier. So let me check the minimum. The minimum against 680, the minimum was 628. It looks like we definitely got an outlier on the minimum side. On the maximum side, it says 1204.7. The maximum is 1577.1. That is outside that range as well. So it seems like we have an outlier on the minimum side and an outlier on the maximum side. We have at least 2. Click, There it is. Because there could be more outliers between the minimum and that range and the maximum in that range. Click. Okay. Let's go to 17. Oh, sweet. Okay. I'll read this one carefully. A researcher reported the mean weight of a sample of grizzly bears as 787.4 pounds with a standard deviation of 46.2. After completing his measurements, he noticed the scale was incorrectly calibrated. Oh no. And reporting each weight 2 pounds too high. In addition, he would like to report his statistics in kilograms rather than pounds. Ooh. If you know how to do those conversions based on what you've done in like science classes, then a unit conversion shouldn't be too bad. But a unit conversion is nothing more than like multiplication division. His corrected mean and standard deviation in kilograms would be what? Now hold on. Okay. Each weight is 2 pounds too high, which means that we would have to subtract 2 pounds from each data point. Let me remind you. If you subtract 2 pounds from each data point, the mean will definitely change, but the standard deviation will not. Based on all of our conversations about it, standard deviation is a measure of spread. Standard deviation is how spread out the data actually is. And if the data is shifted 2 units down, or 2 units up in this case, no, it's shifted 2 units back down, then that standard deviation, that shape spread, is not going to change. So I would take 787.4 and I would subtract 2. But then I would have to convert it into kilograms. So 1 kilogram equals 2.2 pounds. I would have to divide it by 2.2. So let me go to my calculator. 787.4. Yeah, minus 2 divided by 2.2. That's how many kilograms it would be. 357. And I got 3 choices with a mean of 357. Okay. But again, the standard deviation, 46.2. Doesn't change with the 2 pound shift, but does change when you need to convert it into kilograms, because that's multiplication division. So that's 46.2 divided by 2.2, 21. Let's see. Click. There it is. Standard deviation is only affected when you are multiplying or dividing the same number to each data point. Whereas if you're adding or subtracting the same number to each data point, standard deviation is not going to change. Number 19. Let's look at number 19. 19. Ooh, interesting. I already gave away the answer. Click. But let me talk about why that is. Which of the following points has the greatest influence on the strength of the correlation coefficient? Okay. Clearly the answer's, well, I shouldn't say clearly. Let me remind you of something. I have it in my notes. I don't, maybe I could find it real quick. Hold on. Maybe I could find this thing real quick. There it is. I found it. Come on. There we go. R. This problem is talking about the correlation coefficient, which is R. That is how you calculate R. Now, typically, your calculator calculates R for you. So why did I write down this formula? I wrote down this formula because I wanted you to see how R was calculated so you knew the inner workings as to what's going on. R is calculated by taking the z-score of the x and the y value of the ordered pair, multiplying them together, taking all of them for every data point, adding them all up, and then dividing by n minus 1. That is how R is calculated. If you remember how a z-score is calculated, well, it's the data point minus the average divided by the standard deviation. See, the thing is, C is the farthest away from the cluster of data. And because of that, when C is calculated, both in the y direction and in the x direction, the z-score for that data point is going to be larger than everyone else's. As a result, C will definitely have the biggest impact on that data. In fact, let me zoom out a little bit on this page right here. Let me zoom out just a little bit. We took these notes on November 25th of last year. Look what I wrote there. R is sensitive to outliers. R is sensitive to outliers. Yes, I know that C is definitely in line with the line of best fit, kinda. But it is most definitely the biggest outlier that you have there. Excellent. Let me do one more of the multiple choice, and then I'm going to jump back to the free responses. Wait, I already did those. Okay. Ooh, number 31. Oh, let me go back a little bit. There we go. Just to confirm it was C. Yeah. Oh, wait, I already knew that. 31. Excellent. Okay. Number 31. The distribution of the diameters of a particular variety of cantaloupe is approximately normal. What a word. With a standard deviation of 0.7 inches. If the diameter of the cantaloupe is at the 73rd percentile. Come on, you. I'm trying to put something back. There we go. If the diameter of the cantaloupe is at the 73rd percentile, how does the diameter compare to the mean? The distribution of diameters are approximately normal. Standard deviation is 0.7. If the diameter of the cantaloupe is at the 73rd percentile, how does this compare to the mean? I'm going to need a piece of paper. There we go. Because I want to show you exactly what this question gives you and what you are going to be responsible for doing. They want to know standard deviation, or they tell you standard deviation is 0.7. They say it's at the 73rd percentile, and they want to know how the diameter compares to the mean. Okay. I would remind you that z-score is calculated like this. Now, we don't know exactly what the mean is. The distribution, if the diameter is at the 73rd percentile, how does the diameter compare to the mean? Well, 73rd percentile. 73rd percentile. I can figure out the z-score. Okay, hold on. I can figure out the z-score of that. If I went to second vars, I could perform an inverse norm. In fact, you know what? I probably should do this on your calculator. There it is. Let's go second vars, inverse norm, 73rd percentile. Now, the thing is, I don't know the mean and standard deviation. So I'm going to leave everything as is. I'm sorry, they gave me the standard deviation, but I don't know what the mean is. Leave it as is temporarily. I'm going to prove a point here. That's the z-score. Okay, hold up. The z-score should be 0.613 approximately. Now, I'm going to multiply each side of this fraction, because this is actually 0.7. I'm going to multiply both sides by 0.7. So I'm going to get x minus x bar equals multiply by 0.7. Boom. 0.429, I guess it rounds to, or something like that. See, because remember, a z-score is the number of standard deviations you are away from the mean. A z-score is the number of standard deviations you are away from the mean. If it's a positive one, then you're one standard deviation above the mean. Or if it's negative one, then you're negative or one standard deviation below the mean. The question wants to know how the diameter compares to the mean. Oh, look at that. I got that number. 0.429. There it is. Above the mean, because it was a positive z-score. 0.429 above the mean. That's what I got by multiplying by 0.7. Oh, such a weird day. Okay. Let's jump back to one of the free response questions. A problem from 1999. Can you imagine somebody wrote this problem before you were born? Weirdos. The dentists in a dental clinic would like to determine if there is a difference between the number of new cavities in people who eat an apple a day and in people who eat less than one apple a week. Okay, they're going to conduct a study with 50 people in each group. All right. 50 clinic patients who report that they routinely eat an apple a day, and 50 clinic patients who report that they eat less than one apple a week will be identified. I mean, if they're telling the truth. The dentist will examine the patients and their records to determine the number of new cavities the patients have had over the past 2 years. Then they will compare the number of new cavities in the two groups. Huh. Interesting. Okay. Why is this an observational study and not an experiment? Well, there's no treatment. There is no treatment being imposed. In fact, I mean, yes, you're actually seeing these people in real life, and but you're looking back over past data. You're looking back over past data. Not to mention, there's no random assignment. There's no random assignment whatsoever. Huh. Yeah, this is definitely an observational study. All of those reasons I just gave are perfectly valid. Part B. Explain the concept of confounding in the context of the study. Include an example of a possible confounding variable. Now, a confounding variable within this context would basically, well, what are they trying to find out? They're trying to determine the number of cavities, number of new cavities over the past 2 years, and then compare the number of new cavities within each group. A confounding variable would be, well, was it really the number of apples that they ate? Or was it something else that potentially caused or prevented the cavities? If that can't be controlled within an experiment, and you don't know whether it was the apples or something else, then that's a confounding variable, definitely. Oh, one of the definitions I'm reading right here, two variables are confounded if their effect on the number of new cavities cannot be distinguished from one another. They want you to include an example of a possible confounding variable. Well, eating apples isn't the end-all be-all as to whether or not you get cavities. I think one other thing would be you'd have to know what their what is their brushing schedule. I mean, there are some people who they literally only brush once a day. You know who I'm talking about. There are some people who diligently brush 3 times a day, although that's kind of a bit much. And then there's normal people who brush twice a day. I mean, yeah, you would have to know what is their dental hygiene routine or whatever you want to call it. Because depending on what that is, that could definitely confound the number of cavities that they're going to get, regardless of how many apples they eat. Part C. And that's what we're going to wrap up with today because I'm a little short of time, and then I'll kind of explain what you can do. If the mean number of new cavities for those who ate an apple a day was statistically significantly smaller, that's a fun phrase to say. Say it aloud to yourself. Statistically significantly smaller. Anyway, sorry, I'm laughing at myself too. I need students in this classroom because I'm losing my mind again. An apple day was statistically significantly smaller than the mean number of new cavities for those who ate less than 1 apple a day. Could one conclude that the lower number of new cavities can be attributed to eating an apple a day? I mean, it's interesting, but this might be like a veiled correlation problem. But I can see 2 specific ways in which you can't conclude that. Number 1, the best way to make a conclusion like that, a cause and effect, is with a well-designed experiment. And this is not an experiment as we denoted in part A. But number 2, more importantly, we just discussed a possible confounding variable in part B. And because of that, the results being statistically significantly smaller doesn't make a difference because you don't know whether that significance was attributed to the person's, apple eating or their dental hygiene plan or whatever they want to call it. I love this question. It's a thinker. Okay. You have all of these free response questions. You have all of the answers that go along with them. You can review those. I am going to, at some point today, make that multiple choice available to you again for purely practice purposes. If during the course of your studying, you have a question, do not be afraid to email me, even if it's just a single question. I would love to answer it. I mean, obviously, if you have a bunch more, that'd be great. But if you have any questions, email me. I'm going to sign off. I'm going to wave bye-bye to everyone in the classroom because I'm just assuming that you're all here in my mind. That's how I wave to you. It's like a crab. Statistically significantly small. Anyway, I'm going to sign out. Bye-bye, bye-bye, everyone. Bye-bye, bye-bye. Go away. Bye-bye, bye-bye, bye-bye.